Good day. This video clip is intended for the discussion of the terrain visualization. Digital Elevation Model, or DEM, is a three-dimensional or 3D digital model of a surface such as the surface of the Earth. DEM data that can be obtained free from the internet is what we call the SRTM data. SRTM stands for Shuttle Radar Topography Mission. The SRTM obtained elevation data on a near global scale to generate the most complete high-resolution digital topographic database of Earth. Another source of elevation data is Aster. It has a better coverage of the Earth's surface compared with SRTM and is slightly higher resolution. However, it contains more errors than a clean SRTM set. Errors are usually in the form of spikes or pits and can be significant. In QGIS, there are several tools that can process the digital elevation model or the DEM and derive useful information such as hillside, slope, etc. Here, we can integrate the information to GIS hazard data to understand the nature of hazard in the area that you are studying. So let's open the QGIS. Let's create a new project. Let's set the CRS. Okay, then let's save the file. Terrain visualization. Let's have here Philippine terrain analysis. Save. Okay. Now let us open a raster file. So with your given data set, let's have the data set for LabX4 part 3. So let's have vector first. Let's filter it. Shapefile SDN admin. Open. Add. Okay, so this is the Surigao del Norte. Next is our raster file. So go to raster. Select SRTM 41 underscore 90M underscore Philippine underscore UTM. Open and add. Okay. So there is variation here. Okay. So as you can see here, it is the SRTM of the entire Philippines. So what we could do is just to provide only the necessary SRTM for the Surigao del Norte. We could do that by means of using the raster extraction. Okay, so we have disabled first the SRTM 41. Then let's select raster extraction, and we have two types. So we have a clip raster by extent and clip raster by mask layer. Clip raster by extent is intended for the raster to be extracted with a given uh, rectangular extent of the window. On the other hand, for the mask layer, this one is intended if there is an existing layer, like here, what's presented is a Surigao del Norte layer, it will just extract the SRTM for this area only. So let's use the mask layer. So our input is the SRTM 41 and our mask layer is the SDN admin. So run and close. So as you can see, we have already here the clipped mask of the SRTM. So let's change the style. Okay, symbology. Let's change the opacity. Let's have this 40%. Apply. Okay, or let's have an outline. Apply. Okay. So here is the overlay SRTM and the political boundary of the Surigao del Norte. Okay? And we could also use another means of inserting the SRTM. Now, in the dataset provided, there is already an SRTM for the Philippines, but you could also use the plugin available in QGIS. So all you have to do is to click plugin, then manage and install. Click select SRTM in the search bar, and SRTM downloader would be available. So you may install this. Take note, this SRTM downloader, it is a plugin for download of SRTM tiles from NASA. Now, if you will be using this, you will be required to create an account for NASA. Okay? So if you want to use this, you may use this or just use the SRTM provided in the dataset. Okay, so let's close this. So let's hide this clip mask. Okay, so let's have the SRTM downloader. So I'll just show you how it works. You don't need to do this anymore. SRTM downloader. So let's set the extent. Let's have this portion only. Okay, since it will require a lot of downloading, so it will take a while to download. So let's just have this portion up to this extent only. Okay, then download. So as mentioned, it will require you to have an account. So here, download completed. Click OK and close. Okay, so as you can see, there are two files. Okay, so this raster file, okay, downloads the SRTM 1 degree by 1 degree per tile. Okay, now with this, since there are two SRTM, let's just combine this. So raster. So you have to highlight both. Okay, raster, then merge. So miscellaneous and merge. Okay, so here, what we will merge is the north 9. Okay, these two files. Oh, run and close. Okay. And let's hide the downloaded HGT file or remove it already. Okay, and we will just focus on the merge file. Now, let's extract again, mask layer. So we have the merged as input and SDN as our mask layer. Okay, then run, close. Okay, so it's already the masked part. However, there's a change, okay, since because of the different because of the projection. So let's try to use the original file, the merged. Click either of the two. So here, okay, we can see this. So let's have the variation of this SRTM. So clip, and we can change its symbology. For example, hillside. So apply. So here we can see that this is the hillside of the area. Okay. We could also use or set the view of the panel layer styling for us to change directly. Okay, so for example, this one, we can change, since we are in the hillside, okay, we can change the direction of the sun for us to see the shadow of the hill. And we can also change the Z factor. So let's say 5. So there's an effect. Let's increase this. Okay. There are variation with that. And let's compare the SRTM downloaded using the STM downloader and the original SRTM provided in the dataset. Let's hide this one first. Let's create this as hillside. Okay, let's change the name so that we won't be confused. So information source, let's have this as SRTM plugin, and the original SRTM as SRTM from dataset. Okay. So let's SRTM from the dataset. Let's have its hillside as well. Let's change the Z factor to 10. Okay. So if you will check, there is a difference in terms of the provided data, the clarity, okay, of the available contour, the sloping. Okay, so the SRTM, okay, the SRTM plugin has a bit better resolution. Okay, we will stick with this. So here we have provided the hillside. Okay, next, aside from hillside, we could also use the slope. Okay, for the slope, but before that, aside from the hillside, we could also change the color. Let's use the single band pseudo color. Let's change the color ramp. Let's say Viridis, classify, and apply. What was being changed is the SRTM dataset. Let's SRTM plugin. So let's change this. So let's have again the single band. Okay. So let's have discrete color Viridis. Okay. Then let's change our color to turbo. classify, and you could also change to magma and classify. Okay, classify. Okay, so you can vary those depending on the data that you want to reflect. Okay, so let's go back with the hillside. Okay, so you could also change also the rendering. Then we also have contour. Here you would be able to view the contour lines of the area. Okay, next is we could use the slope for portion, the slope rendering. So here we could use raster, then we could analyze it in terms of the slope. So here we can change the ratio. Let's say let's use 5, run. Okay, so because of the color, let's revert it. Quite hard using this. Let's use the SRTM dataset. Okay, so we could have it in variation. Okay, next, let's hide this. Here, we could also use the entire Philippines if you want to analyze this. So this is SRTM 41. If you want to change the contour, here is the contour of the entire Philippines. So for better viewing, let's have the vector of the entire Philippines. Okay, so these are the contours of the mountains. Okay, and you could change it to the color just like what we did a while ago. Let's SRTM. Okay, let's have pseudo color here. Let's make it discrete, and let's use magma, classify, and also we can check again the contours or hillside of the entire country. Then let's exaggerate the z factor. Let's say 5, or let's use 10. Okay, then you can also blend it in response with the GADM41. So darken or multiply. So here we could see the boundaries with respect with the elevations. Okay, so that's it for the terrain visualization. Okay, thank you.